Today we are going to discuss some problems on quadrilateral. So I hope you have seen our last video on different theorems and properties of quadrilateral, so that you are familiar with all the formula and theorems, so that you are ready to solve some problems. So let's get started. What we will do is, let's try to draw a few quadrilaterals and then we will start some problems. So let me draw a quadrilateral. So here is a quadrilateral, and let me put some labels here: A, B, C, D, which is the color of the pen. So what we have to find is the area of the quadrilateral ABCD. What we are given is the length of the sides DC and BC are 10 and 6 respectively, and we are also given the angle associated with these two sides. So given that, we have to find out the area. Now, one of the formula we have discussed is the area of the quadrilateral is AB sine theta, if you remember. Now, AB sine theta is area, where A is one side, A and B are two adjacent sides, and theta is the angle between them. So in this example, we have 10 times 6 times sine 60 degree. So that would lead to 10 times 6 sine 60 degree is around 0.86. That would lead to 60 times 0.86. That's around probably 51. So you can do the math, but you get the problem. So there are two ways you can find out the areas of the quadrilateral. One is AB sine theta, what you discussed. Another formula is also AB and the height, where height is the height of the quadrilateral, which is this. Let me draw a line. It is this quadrilateral, so height. So this is a 90 degree angle. So that is our quadrilateral problem. So let's discuss one more. Now this time we are going to take a trapezoid. So let's take a trapezoid. My drawing is not exactly perfect, but I think you can forgive me because you can clearly make it out what I'm trying to say here. So this is a trapezoid, and put some labels here: A, B, C, D. We have to again find out the area of the trapezoid. What we are given is that we are given that DC minus AB is equal to 30. I think there was a little mistake with the number here. The difference between two bases is not 30 but 6, and the length of different items what you're given is AB is 9 centimeter, BC is 5 centimeter, and also you're given the perimeter is equal to 34 centimeters. So now you have to find out the area. So one thing is from this, let's first write what is the area of the trapezoid, which is half times BC times AB, which is the half of two bases, times height, where height is this is the height. So now, since we don't know, so let's try to derive each of these lengths. So what we know is that AB is 9. Now we know that DC is 9 plus, this would lead to DC equal to 6 plus AB, which is, since AB is 9, it leads to 15. So let's write this as 15. So now we still don't know the height, but what we know is that BC is 5, and we know the perimeter is 34. So let's say 15 plus 5 plus 9 plus AD, we are just adding all the sides, is equal to 34. So this would lead to AD equals to 34 minus 15 plus 5 is 20, 20 plus 9 is 29. So 34 minus 29, which is equal to 5. So looks like AD also is equal to 5. Now if you look at the trapezoid, where we have both the slanted sides as same length, and as you know from the properties of trapezoid, this AB and DC are parallel. So if you draw a line from here, since both sides are same, you can easily derive that these two lines would be parallel. So that means this also is, let's say, EF is equal to 9. So this part, because these two lengths are same, so this part would be equally, this length and this length would be same. So let me draw a line in a separate color. So these two lengths would be same. So now let's try to find out the length of FC. So if we can find at least one length, then we know we know the height of the trapezoid. So FC equals to DE. So if this EF is equal to 9, because these two lengths are same, and again these two lengths are same, so DE plus FC equal to 15, which is the total length, minus 9, which is this part. So this would lead to 6. So that means DE plus FC is equal to 6. So each of them is 3. So let me make some space here. Maybe we can write something here. So DE equals to 3. So this would lead to, now if we can apply Pythagorean theorem on this triangle, this little triangle, let me take a different color. So if this triangle, we can apply Pythagorean theorem here. So we know 5 square equals to 3 square plus h square, where h is the height. So that would lead to h equal to 5 square minus 3 square, which is 25 minus 9, which is 16. So h would be root of 16, which is 4. So the height we get 4. Now if we apply the formula this to find out the area of the trapezoid, so which is half times a plus b 15 plus 9, which is 24 times 4, which led to 48. So I think that's it's pretty straightforward problem, which I hope you understand. Thank you.